Okay, as we go through these two sections, you will find, and you should have taken a lot of the notes, you'll find a lot of terminology that you probably haven't heard of before. Converse, inverse, contrapositive, biconditional. So we need to talk about what those statements are, and then we're going to create them, and we're going to analyze whether they're true or false as we go through. Your assignment's going to seem more like an English assignment rather than a math assignment because you're writing statements. But a lot of our theorems and ideas in geometry are stated in sentences, so we have to make sure that we understand what the sentences are telling us. So quite a bit of vocabulary when you look at both sections. And I think the polygon part we'll probably touch on tomorrow instead of today. So let's start talking about what a conditional statement is. And you should have some of these notes filled out already. A conditional is simply a statement that can be written with the words if and then. Okay? It might already have those words, or part of what we're going to do is rewrite some sentences so it has the words if and then. So a conditional is a sentence that can be written in the form if something, then something. P and Q are kind of the standard variables that we use in logic. The P stands for the hypothesis. I don't know why they didn't use H, but P's for the hypothesis. The hypothesis is the part following the word if. If it is sunny, then it is warm. Okay, so the part that follows the word if is the hypothesis. That's what you begin with. Now in science, what's a hypothesis?
What you believe to be true.
What you believe to be true. So isn't that kind of like what the conclusion's going to be? What the result's going to be? That's not what it is here. So it's a completely opposite meaning. So sorry about that, but that's kind of the way it is. Hypothesis in math is the beginning part, what you're going to start with. The conclusion, like what you would think is the hypothesis in science, is called the conclusion in math and logic. We use the variable Q to represent that most of the time. It's what's following the word then in our if-then sentence. Okay? So if P, then Q. If it is sunny, then it is warm. The hypothesis, it is sunny. Conclusion, it is warm. That kind of thing. The symbols, this arrow, notice it's not above like using it as a ray symbol. This is a different use of it. That arrow means that it's an if-then. P's the hypothesis, Q's the conclusion. So you interpret this as meaning if P, then Q. In a Venn diagram, and we'll do a couple examples that are Venn diagrams, the inner part is the hypothesis, the P part, and the Q part is the conclusion. Okay? So if, let's see, what would be something in a Venn diagram? Maybe you have towns in Nebraska, and then inside it is Seward. So if you live in Seward, then you live in Nebraska. That would be the idea of a Venn diagram. All right, so we're going to try and pick out some hypothesis and conclusion and do them in conditionals, because if you have the sentence with the words if and then, it's real easy to pick out the hypothesis and conclusion. Identify the hypothesis and conclusion of each conditional. Let's do a few together, and at times I'll have you pair up, and we were doing the front row, second row, paired together, and third and fourth. Looks like in this row we're missing somebody, so why don't we go, you two will pair together. We'll make a group of 3 today then. And let's see, how was I doing? These paired up, so let's go. These first 2 and these 3 work together. All right, so today we'll start an example together. So if today is Thanksgiving Day, then today is Thursday. I simply want to know what's the hypothesis, what's the conclusion. I'm not asking if it's true or false, just what's the hypothesis? Who thinks they can tell me which part is the hypothesis? We'll do this together for the first one. Hypothesis is what? Haley?
Today is Thanksgiving Day.
Correct. She did not say the word if. It's just a statement that follows it. Okay, then the conclusion is, Vanessa?
Today is Thursday.
Today is Thursday. Second example. With your partner. Discuss.
Is a rational number. Good job.
All right. Hypothesis, a number is an integer. Conclusion, it is a rational number. Not including the words if and then. Just those are the keys to here's the hypothesis, here's the conclusion. But sentences often don't have the words if and then. So on the next ones, we're gonna have to first rewrite it, at least in our mind, how it would be with the words if and then we can easily pick out the hypothesis and conclusion. So you're gonna have to figure out what comes first, what do you begin with, and then what's the result or the conclusion about them, okay? Which thing is dependent upon what you start with. So my sentence is, a number is divisible by 3 if it is divisible by 6. Read that a few times. Decide what you think the hypothesis is, the conclusion. Just how would you say that with the words if and then? You see the word if is already there? Okay, so discuss with your partner quickly.
You wouldn't be like flipped. You do it like either way. If a number is divisible by 3, then it is divisible by 6.
Your last name is spelled K.
I think it's the second way.
Okay, I'd like first to hear it with the words if and then. You told me that if is already there, so it shouldn't be too hard to add the then to make it a sentence. So who can say this sentence with the words if and then? Oh, yeah.
If a number is divisible by 6, then it is divisible by 3.
Correct. So by what she said, the hypothesis would be it is divisible by 6. The conclusion, it is divisible by 3. The number is divisible by 3. Question on that one? Question? All right, how about the sentence? 2 angles that are complementary are acute. I want you to write a conditional statement from that sentence. What's a conditional statement? It needs to have the words if and then. Don't change the meaning of it. Just figure out what comes first and what's the result or the conclusion part. Say it in a sentence that makes sense. Discuss with your partner.
Then they are acute.
If 2 angles are complementary. 2 angles are acute.
They have to be. Because it can't be, yeah. Even if it was 89 and 1.
Wait.
I think, do we have the back or have YouTube?
If 2 angles are complementary.
Last week we did the sideways. Now we're doing the back. I need to give you different seats so we have different partners. Okay. Which group can tell me the conditional statement? Group capable of doing this? All right, Nora.
Huh?
How's
Oh.
your group come out?
If 2 angles are complementary, they are.
And then the hypothesis and conclusion are coded there. Yes.
Is there such thing as a 0-degree angle?
Is there a 0-degree angle? I would say,
If that's a
I would
line.
say no, that it doesn't. I don't think I'd even call that a line.
It'd be like a real
It'd be 2 rays that are really the same ray, so it would be just 1 ray if it's a 0-degree angle. So I'd say that doesn't exist at
So
all.
I could say that a
So-
right angle and a 0-degree angle are complementary.
No. Because a 0-degree really is no angle at all. All right. How about this sentence in a conditional statement?
If your partner, then they eat worms.
No, you're all wrong. Something is
I said that. I said that.
You said it way different.
You really know what
I flushed it out.
Okay, All right, up here. Okay, the bird part was the hypothesis. The conclusion, the result, or the thing about it is eating worms. So something like, if an animal is a bird, then it eats worms. Now, if you had your words a little bit different, like if you said, if you are a bird, then you eat worms, I'd say, okay, yeah. But if you had it backwards, if you had the worms in the hypothesis, no. The worm part is the conclusion.
If you are a word.
I can't hear you.
If you are a worm.
No, like,
No.
you are not,
Bird
if a bird dies.
What if a bird eats it?
Okay, we want to make it, Malia, we wanted to say what this says. All birds eat worms. So what's the thing we start with? We're starting with a bird. We have a bird to start with. And the conclusion about them is that they eat worms. So are there some related statements? Yes, but you're kind of changing the meaning a little bit there.
Did you say if birds eat worms, then all birds eat worms?
That doesn't make sense.
It doesn't.
Birds are all birds. Okay, any questions how you get the sentence out of that one? Okay, how about one more here?
That's what I was thinking.
If it is snowing, then there is no. If it is snowing, then there
All right, up here. I think everybody got that one, and you're thinking snowing, then there's no school. So the hypothesis was it is snowing, the conclusion there is no school. So a key word in here, it wasn't an if, but when. That kind of tells you the sequence of things. When it's snowing, then there's no school, so that helps you get the hypothesis.
Which sentence you could write?
All right, this is the one I'm after. Okay. But this was just helping kind of figure out, that's really the hypothesis, and that's the conclusion, just some thinking along the way. All right, here's a Venn diagram. Now think what the notes say. Which one's the hypothesis? And I'm just gonna have you raise your hand instead of share this time. Which part's the hypothesis, which is the conclusion, and make it make sense without changing the meaning of it. All right, Anna?
If you are a blue jay, then you are a bird.
Okay, I would agree with that.
If an animal is a blue jay, then it is a bird.
Okay, I think that's what I had.
Oh, you did.
All right, so the blue jay is the hypothesis, the conclusion is a bird. And we're not even thinking, or shouldn't be thinking, is it true in that order or not? You're just using what's the hypothesis, what's the conclusion. Okay? Now we'll start thinking about true or false. Okay, now you probably have some notes about truth values, but I don't think this chart was in your book, so let's get that chart added. And we'll talk about what that is. Okay, so now we're going to take a look at, are those statements true or false? What's the truth value of it? Now, if you think about what we did yesterday, a statement, a conditional was false if you could make a counterexample. But when you made that counterexample, you had to use what kind of thing it was talking about. Like it maybe said, if n is an integer, if n is an even number, or something like that. You had to use what the hypothesis, which we didn't have that word yesterday, but you have to have what that tells you to begin with, and then see what the conclusion is. Is the conclusion about it correct or not? If we could make a counterexample, then it was false. That's really what this chart is pointing out to you, but showing you all the combinations. Okay, so up at the top still, a conditional is false only when the hypothesis is true and the conclusion is false or incorrect. In other words, you can create a counterexample. So the counterexample, you pick something that fits the hypothesis. So the hypothesis would be true, but we want to show that the conclusion is wrong or false about it. So if you could make that up, it was a false conditional because you can make a counterexample. That's the only way you can get a false conditional, if you can create a counterexample. So these other combinations all would have to be considered true because you can't make a counterexample. The first one's gonna be simple for you. If you have something that fits the hypothesis, it fits the conclusion, that's gonna be a true conditional. Now, these bottom ones are gonna seem weird when we look at an example of them, and we don't do too many examples. But if the hypothesis is false, in either case, in other words, you can't get something to fit the hypothesis, to even make a counterexample. So if you can't make a counterexample, it doesn't matter what the conclusion says, that statement's gonna be true, because you can't make a counterexample. You're gonna run across one of those on your homework especially. So just keep in mind, if you can't make a counterexample, it's true. Let's see if we can make counterexamples or not. If this month is August, then the next month is September. True or false? Okay, that one's true because we know September or August last year was followed by September. If two angles are acute, then they are congruent. If it's false, I need a counterexample. Who's got counterexample? Counterexample. Tracy? A 40-degree angle and a 50. Did she come up with two angles that are acute?
Yeah.
Yeah. They are congruent. Was that correct conclusion about them? No. So she found one that fit the hypothesis but showed the conclusion incorrect. Okay. Did you want to add something?
No.
Okay. So two angles, I had 80 and 30, but we were coming up with counterexamples. Okay. If a number is odd, then it is divisible by 3. Determine true or false, counterexample, and let's not shout it out so much. Let's think and raise our hand. So others have time to think. True or false? Thomas?
False,
Counterexample?
like
5 is odd, but you can't divide it by 3. Correct. He came up with a counterexample, so that would be a false statement. All right, we did some of those counterexamples yesterday. So let's go on to negation. Negation is kind of hard to define. I kind of struggle with words. But negation of a statement, if your statement is as in variables p, then the negation is not p. So if my statement is, and notice it's not a complete if-then, just like the hypothesis. Okay? If my statement said it is sunny, the negation of it would be
It's not.
it is not sunny. If my statement said it is not warm, the negation, it is warm. Okay? It is not orange. It is orange. It is Wednesday. Monday. It's not Wednesday. So you're just negating it by doing, you might say kind of the opposite of it, but you're not changing the words. Just if it sounded positive, the negation sounds negative. If it sounds negative, the negation sounds positive. Does that make sense? All right, now we're going to use those negations to create the 4 different, actually 3, other if-then statements that are related to the conditional, but they're not saying the same thing all the time as the conditional. So your conditional, and I think I'll do some notes on the board so we can look at it. Conditional was if P then Q. That's kind of the standard conditional. Conditional if P then Q. All right, a related statement is called a converse, or at least one of them. A converse is switching the hypothesis and conclusion. So if Q, then P. So you change the order of what you start with and what you end with. So that completely reverses the idea. The inverse involves negations. Okay, and this symbol, that squiggle in front, means negation of P. So if not P, then not Q. So it's in the same order as the conditional, but you negate both parts. And the last one was the contrapositive, which you do what? You negate and switch the order. Or if you want to say it's the same order as the converse, but you negate each part. All right, so we're going to create these sentences. I think you have an example related to cats and paws. I think that's my first set of examples. All right, so my original statement is, if an animal is a cat, then it has 4 paws. Now for us to make these easily, let's pick out what's the hypothesis, what's the conclusion. So what's the hypothesis of our if-then? An animal is a cat. That's P. And then the conclusion, it has 4 paws. That is what we'll use as Q. So when you negate those, they're going to have the word not in them. So what is the converse? Going to sound like. If it has 4 paws, then it is a cat. Yes, I put animal in there. If an animal has 4 paws, then it is a cat. That's called the converse. What's the inverse going to sound like? Okay, I think I'm hearing it right. If an animal is not a cat, then it does not have 4 paws. That's called the inverse. And then the contrapositive. If an animal does not have 4 paws, then it is not a cat. That's called the contrapositive. So I know those weren't in the book, so get those written down if you needed those examples. There was a butterfly one? Okay, so you did the butterfly one in your notes, maybe? Okay. And that matches, you wrote it for the, you might want to put it up there also, then, so it fits. All right, anyone still need the screen? A little bit. I'll give you another conditional statement and have you create each of these. So if you want another example in your notes, fine. If you want to grab the newly cleaned marker board. I guess the marker board wasn't clean, but the supplies are a little less German. Okay, let's have you make the converse, inverse, and contrapositive of this conditional statement. If you sit still in class, then you get candy is the if-then.
Is that true?
Don't know if it's true or false, it's just a statement. All right, so now make the different related sentences. The sentences you're making are not the same as that one. Some are, one of them is the same, really. We'll talk about that in a little bit. They're related statements. Sentences start with a capital letter, capital I on your if, and then end with periods, a period. I believe grammatically the comma in there before the word then would be correct. Get your prepositional phrase set apart. converse, if you get candy, then you sit still in class. Inverse, if you do not sit still in class, then you do not get candy. Contrapositive, if you do not get candy, then you do not sit still in class. Did not sit. I don't know if there's a different way to say that. You did not. Maybe did not instead of do not. Okay, question on those sentences? Okay, now let's talk about whether they're true or false. So not those candy ones, we're gonna go back to the cat ones. Okay, now as we think through whether those cat statements are true or false, don't mutilate the cat, and we're gonna assume that they were born with 4 legs. They're not gonna do something really strange to them. I know there are some things that happen, but in general, true or false, if an animal is a cat, then it has 4 paws. True, so in your notes, mark that that's true. Okay, the next one was the converse. If an animal has 4 paws, so think of an animal that has 4 paws, is the conclusion correct? It's a cat? No, counterexamples? Dog. Okay, now horse probably can't be used for a counterexample. Rabbit. Hamster. Okay. All right, so you have to make sure you're picking an animal that has 4 paws as the counterexample idea. Okay, how about inverse? If an animal is not a cat, so think of animals that are not cats, is it correct? Then it does not have 4 paws? Counterexample? Okay, a dog is an animal that's not a cat. And is it correct that the dog does not have 4 paws? No, that's an incorrect thing. So that's a counterexample. So this statement is false. Okay, besides dog, what could we have?
Oh, rabbit.
Rabbit,
Komodo dragon.
Komodo dragon.
Is that paws?
Does it have paws?
Koala.
What kind of claws? Well, it's not a cat.
Koala is in a bear.
Okay, could we use a horse on this one? An animal is not a cat, we can think of a horse. And is it correct that it does not have 4 paws?
That's correct.
That one is correct. So that one's not a counterexample, that one would be an example of it. So that's not a counterexample either, is it? Okay, and contrapositive. If an animal does not have 4 paws, so you can think of a horse now, then it is not a cat.
It's true.
Everything you think of that doesn't, every animal that does not have 4 paws, it's not a cat. Okay, so notice on that one, they were not all true. They were not all false. There are logically equivalent parts to this. Which ones are logically equivalent have the same truth value. So the conditional is logically equivalent to the contrapositive. That will always happen. So in your notes where you're saying which ones are logically equivalent, the conditional is logically equivalent to the contrapositive. And then the converse is always logically equivalent to the inverse. They might all be true. I don't think they can all be false. But if you have some of each, you're going to have 2 that are true, 2 that are false. And they're going to pair up in this way. All right, so let's, you got that written down, which ones matched up? Let's see, let me go back. The ones that were matching up, conditional went with the contrapositive. And then the inverse and the converse. So these 2 logically equivalent.
Oh, yeah.
And in the middle. All right, let's look at another statement. Okay, these are about midpoints and segment bisectors. So I'll give you the statement. You write down on your marker board, is this true or is this false? Okay, we'll go through all four of them. Okay, the first statement, so you have to think of what you know from chapter 1. If a line intersects a segment at its midpoint, then it is a segment bisector. True or false? And I have a feeling I put the true or false after each one. So that one is true. True, okay. The converse, when you switch the order, if a line is a segment bisector, then it intersects a segment at its midpoint. On your board, true or false? Show me. Should be true. A line's a segment bisector, it always goes through the midpoint, that's part of the definition. Okay, the inverse, with the negations in there, if a line does not intersect the segment at its midpoint, think of lines that don't intersect at the midpoint, then it is not a segment bisector. Now, if you're kind of wondering, this one is logically equivalent to the converse. So since the converse was true, this one would be true also. And the contrapositive, if a line is not a segment bisector, then it does not intersect a segment at its midpoint. True or false? Show me. That one was also true, logically equivalent to the original one. So there's an example where they're all true. Definition things will be true all the way through, no matter which way you switch it. And when we get to the biconditionals in the next section, true works there also for definitions. Okay, here are the 4 different ones. This is the screen I was thinking. Answer all 4 of them. True or false? Think about which ones are logically equivalent, and that can help you reason through. Maybe create a counterexample. Discuss with your partner.
Here, all spot. Yeah.
That's true.
Uh-oh. Counterexample could be a litigant and arguments.
Or like a different
Okay, did you agree?
Yes.
Okay. Which ones have counterexamples?
Conditional and the contrapositive.
The first one and the last one, the conditional and the contrapositive, correct. What were counterexample ideas? Weekends, summer days, maybe a snow day, maybe December 24th, at least we hope so. Okay.
Maybe not next
All right, so I think all of you filled in your notes. The conditional and the contrapositive are logically equivalent. Converse and inverse are logically equivalent. They could all be logically equivalent, but not always. And the law of contrapositive that you see at the end of that page, that's just a law that is stating that the contrapositive is logically equivalent to the conditional statement. All right, how do you feel about that section? Just gonna have to do some memorizing on how you create these. So this little chart right here is something you need to commit to memory. And then you get the ones that are logically equivalent. So if you flip into the 2-4, we'll finish up by talking about biconditional statements. Okay, a biconditional statement is a combination of two of the statements that we were just looking at. What two combine to make a biconditional? What's it say in your notes or in your definition? What two combine? Okay, if P then Q, so the conditional statement, if P then Q, and the converse, if Q then P. So the two that go reversing, I guess, combine to make what's called a biconditional statement. So that means it could go both ways. Biconditional statement has some special words, if and only if. And it's not starting with if and only if. Notice it starts with one of the statements, then if and only if, and the other statement. So it's written in the middle of it, so that you can think of it going both ways. First thing, then last thing, then first thing. You can also show it with a double-headed arrow. This arrow in logic means if and only if. There's an abbreviation here, IFF, that also means if and only if, kind of like in texting mode. But it combines both the if P then Q and if Q then P. So we're going to take a biconditional apart to come up with both of those separate statements. We're going to start with one of them, create the converse, and then make the biconditional. So we're going to go both ways on this. Okay, so here's a conditional statement. I want you to write the converse and then write the biconditional form of this definition. Let's see if we can kind of do this together for the first one. So what would the converse of this conditional sound like? Just what we were doing, make the converse. Raise your hand if you think you can read me a sentence or say a sentence that's the converse. Right? Converse. I believe she did say the right thing for the converse. Okay, now we want to put those two together into a biconditional statement. Think what words need to be there and where they are in the sentence. What would the biconditional sentence be?
If in both
Okay, we
measures.
started with if. No, don't start with if. Start with an angle.
And angles.
Okay, what's the P part and what's the Q? The blue part is the P,
P and the red
red part's Q. And I want you to make a biconditional statement. That's like P, if and only if, Q. Combining these two things. Ready to try it? Looks like he wants to pass to somebody else here. Hey, Vanessa?
An angle is up to if and only if its measure is greater than 90 and less than 180.
I believe she said it right. So I just didn't we didn't want it to start with the word if, right? We needed to put that in the middle there, okay? So an angle is obtuse if and only if its measure is greater than 90 and less than 180. Give me a thumbs up or down if you understand that as you see it. All right, try some more examples, it looks like. Okay, this one, I'm giving you the biconditional. So I want you to give me the conditional and the converse. Discuss this one with your
So it'd be,
The solution is neutral if and only if its pH is something. Is that correct? That's correct.
All right, sounds like your discussion died down there. So, was this your conditional? If a solution is neutral, then its pH is 7. And your converse, I put the word solution up there. If a solution's pH is 7, then it is neutral? Yeah? Okay. So there's another example. Write the conditional statement and converse within this biconditional form. Okay, this is the definition of an acute angle written with the words if and only if. What are the conditional and the converse that combined made that?
If it's greater than 0 and less than 90, then obviously.
Okay, let's see if that one made sense. Conditional and converse? If your group did it right, raise your hand so I can tell. Making sense? Okay, looks like we're getting that part. All right, so I made one here that had, a negation sound to it. So is that gonna change any of your thinking? Who can tell me what the conditional statement is without discussing with the neighbor? What's the conditional from this biconditional, and what's the converse from the biconditional? What is something with the word not in there? See if that's confusing. Okay, give me the conditional statement. All right.
If Charlie's not on the ineligibility list, then falls in.
I think he gave me the converse. Okay? We do the conditional. Alyssa?
If Charlie's just going to the musical, then he is not on the ineligibility list.
Yes. Because the P is first in the biconditional, so that should be first in her if then. Okay? And then what was read earlier was actually the converse of it. Okay? I think we've got that. Let's see. For the conditional, write the converse in a biconditional statement. So the converse, now give it from Kate, what's the converse?
If x equals 9, then 5x minus 8 equals
Okay, in case you didn't hear him, that's what he said. Okay, and a biconditional, think what words it needs to have. Toby, how can I from you? Biconditional.
so 5x, would you start, did you start?
Can you start with 5x?
Or do you have to start with x?
Which part is the P? Okay, the conditional,
5x.
the conditional has the P to start with. So what you started with was right.
Okay, so 5x minus 8 equals 36.
37.
Or if and only if x equals 9.
Yes. So the if and only if.
I just can't talk.
All right, I think we've got that. I'm gonna skip this example. Now, are the biconditionals true or false? I think is the last part that we need to talk about. Okay, true or false? For a biconditional to be true, both the conditional and the converse have to be true. So we need to take the biconditional, pull it apart, and then look at each of those. Are the conditional and converse logically equivalent? Which ones were logically equivalent? Converse was logically equivalent to inverse. Conditional was contrapositive. So conditional and converse aren't logically equivalent. So that means one of them could be true, the other could be false. They might both be true. They're probably not both false. But we have to pull apart the statement and then consider each part. So determine if this biconditional is true. If it's false, give a counterexample. So pull it apart. If an angle is a right angle, then its measure is 90. True or false?
True.
Converse, if an angle's measure is 90 degrees, then it's a right angle. True. So it's true both ways. Biconditional would be true. My note at the bottom might be something to pay attention to. Definitions are always true biconditionals. Definitions are always true biconditionals. It's true going both ways. That's what a definition is, basically.
Your if in your biconditional has to
Do I, in my biconditional, yes it does.
be X. It's supposed to.
Because I don't want it to be if. Doesn't a biconditional mean if and only if?
Yeah.
And that's the abbreviation texting version of if and only if. I mentioned that a little bit earlier. Did not catch that. It was one of those quick things. But IFF does mean if and only if. Okay? All right, it was a quick go through. Okay, is this biconditional true or false? Okay, let's pull it apart. Tell me the conditional. Conditional. Gracie.
If a rectangle has side lengths of 12 centimeters and 45 centimeters, then its area is 200 centimeters squared.
She gave me the conditional. Was that true or false, class?
I'm assuming true.
Sure. Now think, how do you find the area of a rectangle? You multiply those two measurements, right? So what's 12 times 25?
Yes.
12 quarters would be $3. That's true. Okay, the converse would be what sentence, Abram? You probably need to get rectangle in there somewhere. But if the rectangle's area is 300 square centimeters, then it has side lengths of 12 to 25. So think of rectangles that have areas of 300 square centimeters. True or false that it's a 12 by 25? False. Got a counterexample? Okay, a rectangle that's 30 by 10 would have that area, but not be what it says. And there could be others, maybe a 1 by 300 or a 2 by 150. There are such rectangles. Okay. So that, you can get a counterexample on that one, so that part's false. So the biconditional is
False.
false. And what's its counterexample? That 30 by 10 rectangle we were thinking of would work for a counterexample. Any question on thinking through that one? That one wasn't a definition. And it doesn't mean that biconditionals that aren't definitions are always false. No, I don't want to say that either. But just to make sure you realize it could be different there. Okay, let me zip through that one. And we need to talk about the definitions of like angle bisector and such. A definition is a statement that describes a mathematical object. It's always a true biconditional, I said. So let's think back to chapter 1. Think of your definition of congruent segments. And all we're going to do for these last 3 examples here is write them with if and only if. I don't think you have the congruent segments in your notes. So we'll do that one as a sample. Congruent segments, tell me what they are. Okay, segments that have the same length. So how would we put that in a sentence with the words if and only if? No?
The segments are congruent if and only if they have the same length.
And I went with just 2, so I put 2 segments are congruent if and only if they have the same length. That would be the definition written with if and only if. Okay, now one's in your notes. Midpoint, how would you do that definition with the words if and only if? You might have to start by saying a point is a midpoint, if and only if. What did that definition say? How do you clarify it's in the middle? Bisects, how do you know it bisects? Divides it directly in half, tell me more, you haven't said the exact words I mean.
Are congruent.
Okay, congruent? In there. Okay. Point is a midpoint, if and only if it divides a segment into 2 congruent segments. Why was I so picky? When we get to use this definition, we want to be able to state 2 segments that are congruent. So we've got to have those words in our definition. And the last thing we'll do from this section is the angle, or today anyway, is the angle bisector definition with the words if and only if involved. So think how we did this last one. I started out with a point is a midpoint. How would you start out the angle bisector? What is an angle bisector? It's a ray. So maybe start a ray is an angle bisector. If and only if. Abbreviated or written out. And then you got to know the definition to finish it.
If it divides an angle into 2
Correct. Kind of patterned after our last one. A ray is an angle bisector if and only if it divides the angle into 2 congruent angles. And I think tomorrow we'll take a quick look at the polygon definition there to make sure that you know that in the future. And they gave us that so that we can do some problems related to polygons. So I think we'll stop right there and do our problems. Like I said, it'll seem more like an English assignment because you're going to be writing out some sentences. But some of them have math background to them. These are the problems to be doing. Okay, the page 84 is the page that had the converse, inverse, contrapositive. The page 99 has the biconditionals. Try not to go too wild, but enough for you to get the idea. I think that those 2 lessons are probably unfamiliar material, something you haven't heard before.